10-1 square root functions, talking about what they look like and just features of a square root function. So the parent function again is f of x equals the square root of x. But we also have this other formula that we can use where they get a little bit more complicated and translate on the coordinate plane, move around with h and k values. So we'll look at what that means. We're first going to be asked to recognize the domain and range. Remember, the domain is asking you what are all the possible x values, and range is asking what are all the possible y values. And there's two different ways that you're going to enter that into the computer. One is in the form of an inequality, which would be 8x is greater than or equal to h. If it's range, though, we're talking about y, so it'll be y is greater than or equal to k. And that's basically telling us what values can we put in for x and y that will actually work for this function. But if it asks for interval notation is with brackets and parentheses. So it's going to look like this. This is meaning h, we're including that value of h with a bracket, and then the infinity sign is matched with a parenthesis showing that it goes on forever. All positive values that go on forever. Same thing here, the k value, it means that it includes whatever that value is, whatever number k is, it includes that value, showing the bracket, and then again with the infinity sign showing that it goes on forever. And then the minimum point on the graph would be hk. Now when we say minimum point on this graph, it's a little bit different than parabolas, for instance, because we don't have that looking like a vertex, kind of, right? We just have this line, this like weird curve. So I want you to know that the minimum point on a square root function is going to be this point right here. It's still the lowest point on the graph, but you know, parabola would have the rest of the curve, but that would be sideways for this one. So this would be the minimum point. The origin is the minimum point for the parent function for a square root. Also, we need to know that there'll be no x-intercept for a graph if the k value is positive, and there's going to be no y-intercept if the h value is negative, if it's shown as a negative inside the square root. So let's think about what that means. I have an example right down here. G of x equals the square root of x minus 2 and then plus 3. What this is telling us, we can know from these h and k values that if we're comparing this graph to the parent graph, right, which is graphed right here, this graph right here is actually translating 2 units to the right and 3 units up. So, and that is because this -2 in here, remember our h value always has the opposite value on the graph. So if it's showing that negative in here, it means that it's actually moving to the right, not the left, like we would think for a negative number. So this is moving 2 units right, and then because this is a positive 3, it's going up 3 units. As I said up here, for this graph, right, our minimum point would be hk. Well, the value of h is positive 2, and the k value is 3. Meaning, if we went up to this graph, our minimum point, we could plot at 2, 3, over 2, and up 3. And then it would have this same curve, but the minimum point would here. And as you can see, this graph is above that graph, and it's way away from, this is our y-axis and our x-axis right here, and this graph right here, this new one, doesn't cross either of those. So that's what I mean about no x-intercept, no y-intercept. If we're moving this graph to the right, it's not going to be crossing the y-axis. And if we are moving it up, it's not going to cross the x-axis. So we can know a little bit just by looking at the function itself and know some things about what the graph looks like. The domain For this one, the domain, well, as an inequality, we know that it would be x is greater than or equal to h. And again, the h value is 2. So if we think about that in terms of the graph, all the x values, this is saying that all the x values have to be greater than or equal to 2, positive 2. Well, positive 2, if we go over 2, right, it's saying that this line right here, this graph, the only values that work are everything to the right, more than positive 2. Same thing for the range. Y is greater than or equal to the k value. Our k value is 3. That's telling us this is at positive 3. So this graph right here, and I'll draw it darker so you can see it, is above positive 3. Okay, so when you think about domain and range, think about where the graph is located on that plane, and that's what we're talking about. It has to be it has to match these values. Otherwise, when we're in this side, that's where the graph is not. All right, so that's what you're going to do. You're going to look at these translations. One other quick example, just to show you the opposite. If we had x plus 2 and then minus 3 out here, well, what would the translation be? It would be the opposite. We would now be going left 2 units and down 3. So left, our minimum value is going to be here, and now we have the curve that goes like this. So eventually we will cross that x-axis over here, and we will cross the y-axis. So some of these graphs have x and y intercepts, and some of them don't. But that's what you're going to be doing on your assignment. You're going to be just telling me what is the domain and range of these types of functions, and how is it translating? What do you know about the units? If it's in this format up here, what can you tell me about the h and k values? How is it translating? How is it moving around on the coordinate plane?